Now let us start with the sixth question. In sixth question, we have again how we are starting from first and second material, and we need to produce the third one. The third one is 4,4-dimethyl 2-cyclohexanone, and you know that you can see how complex this structure is, and it's quite astonishing to know we can achieve making this complex structures within some few simple steps. The first one is just at the second one at the first one in a strong basic condition, so that the alpha hydrogen, which is acidic, can be removed, and we get Me2C minus CHO, that is a carbon ion, and it can react with CH2 double bond CH CO CH3. This can react with terminal alkene, and the pi bond of alkene can go on C. This is basically what we call as Michael addition. The name is not that important, the concept is. Now, in this reaction, our initial product form is aldehyde over here, carbon ion over here, double bond of CH3. Now, by providing H plus, we get double bond O CH3 CHO. So now let us see how to proceed. After getting this compound, if we add C2H5ONA to it and heat it, that is basically Claisen-Schmidt reaction, as we are having aldehyde or carbonyl group without an alpha hydrogen and carbonyl group with alpha hydrogen, no alpha. Therefore, this, when heated with C2H5ONA, and it forms O minus, then double bond O, and then this is reacted with H plus to form also double bond O, and finally it is dehydrated with the help of sodium bisulfate, here sodium hydrogen sulfate, to form the required compound. So in this type of questions, you should first of all see that initially the problem may look tough, but when you apply some basic reaction, you may get it that whenever we deal with any aldehyde and keto, and we want some compound which is twice as bigger as them, or which is quite complex compared to the original compounds, then you should know that this compound will undergo the miscellaneous reaction in which aldol condensation, manganese zero, Can0, or Claisen-Schmidt or Tischenko or Perkin type of reaction will go. And more than important than memorizing this reaction, the important point is just see the reagent, which reagent we are going to use, and just see whether the hydrogen, alpha hydrogen attached to aldehyde or a keto group or a carbonyl group is there or not, and if if it's there, so can it be abstracted? If it can be abstracted, then can it be used in the reaction? So this is the basic idea in which you should follow so as to solve any sort of difficult question, whichever comes in your path. Thanks. So now let us start with the question number 7 and let's see how to solve this type of paragraph questions. Question number 7 tells us an organic compound A on treatment with ethyl alcohol gives A. carboxylic acid, B. and a compound C. Hydrolysis of C under acidic condition gives B and D. Oxidation of D with KMnO4 also gives B, and the compound B on heating with calcium hydroxide gives E, whose molecular formula is C3H6O. And then we have E, which does not give tolerance test and does not reduce Fehling solution but forms a 2,4-dinitrophenyl hydrazone. Again, we need to find A, B, C, D, E. So the basic approach to solve this kind of paragraph is, first of all, write the reactions in terms of A, B, C or whatever they are given in a raw form or a first. Like A with C2H5OH gives me B plus C, where from the quotient P is an carboxylic acid. Now, we have also been given that C reacts with H plus to give me B plus D, and from D I can get B if I reacted with KMnO4. Finally, I have P with calcium hydroxide gives me on hitting C3H6O, that is E. So now after writing this reaction, we need to see from A, B, C, D and E which compound's property is given or which reaction we can solve first, and as soon as we solve first, just try to relate it from others and solve them simultaneously. So we know that compound E must be a ketonic compound. Let us find out why it is. It should be a ketonic compound as it does not give tolerance test. And even it does not reduce Fehling solution. So, but it forms 2,4-dinitrophenyl hydrazine, and only carbonyl compounds form 2,4-dinitrophenyl hydrazone, and hence it has to be a ketone, and therefore its structure, as it does not give a tolerant test also and Fehling, therefore its structure should be CH3, C double bond O, CH3. Apart from that, this is the smallest ketone, so it just comes from the molecular formula, only using our basic concepts. Then we know as E is obtained by heating P with calcium hydroxide, the compound P must be then CH3COOH, which is acetic acid. And now, as we know that B is obtained by oxidation of T. T is obtained when we oxidize T. Therefore, the compound T must be an alcohol with a molecular formula CH3 CH2 OH. Now, we know that series B and D are obtained by acid hydrolysis of C. We did acid hydrolysis of C to get B and D. Therefore, the compound P must be CH3 C double bond O C2H5, that is ethyl acetate. And finally, since the compound B is acetic acid and C is ethyl acetate, and they are obtained by treating A with ethanol, we get B plus C. Therefore, the compound A must be an anhydride. CH3CO whole twice O. This is compound A. So let us summarize how the reaction went. It is CH3CO whole twice O. It is acetic anhydride with an alcohol forms acetic acid and ethyl acetate. Then this was compound C, it was B, and this was A. C on reaction with H plus gave us again acetic acid, which was compound B, and ethanol, which was our compound D. And ethanol on oxidation gives acetic acid, as we all know. And finally, compound E with calcium hydroxide gives me acetone. So this is the method you should proceed with all the paragraphs question, and that's it. Now let us start with question number 8 and see how to solve it. We are given 2 moles of an ester A are condensed in the presence of sodium ethoxide to give a beta keto ester B and ethanol. On heating in acidic solution, B gives ethanol and a beta keto acid, which on decarboxylation of C gives us 3-pentanone. We need to find A, B and C. So again, it's a typical paragraph question, and just by seeing the basics of the mechanism which we learned, we can do this question very easily. We know that the reaction of 2 mole of an ester giving beta keto ester and alcohol in the presence of sodium ethoxide is known as Claisen conduction. That is 2 mole of an ester when reacts giving beta keto ester and alcohol in presence of ETONA, it is Claisen condensation. Now let us give the reaction assuming a R and R dash. We get R CH2, C, double bond O, O, R, dash. This is what our ester is. If this ester reacts with itself, that is 2 mole of ester in presence of EtO minus, we will get this both are A. We get R, CH2, C, double bond O, CH, R, C, double bond O, R dash plus R dash OH. This is beta keto ester, which is E, and this is alcohol, which has been given as ethanol in the quotient. So here from directly R dash comes out to be C2, CH2, CH3. So now we know R dash. Let us proceed with B and the next reaction which was given. So R, CH2, C, double bond O, CH, R gives me C, double bond O, R dash, which in acidic medium plus heat gives me CH2, C, double bond O, CH, R, C, double bond O, OH plus R dash OH, which is an ethanol over here, and a beta keto acid over here. This compound is given as C, and this was our P. So now our compound C on heating as given in question gives the pentanone. So let us see this on heating gives R, CH2, C, double bond O, CH2, R. So clearly R is CH3. Therefore, our compound A, B and C are A is CH3, CH2, C, double bond O, CH2, CH3, B, CH3, CH2, C, double bond O, CH, CH3, C, double bond O, C2, H5. And finally we get a C, which is CH3, CH2, C, double bond O, CH, CH3, C, OOH. So this is what ABC are.
Moving on to question number 9. In this question, we've been given a compound which looks very complicated to me, and we need to make it react with an acidic medium, right? H plus ions are present, and A is the product being formed, and we need to find out A. So let's move on to the solution.
Yeah, first of all, we know that this compound is unstable. The reason is high strain due to COC cyclo bond.
Right. there's a 3-membered ring in which an
Yeah.
oxygen is present. So yeah, obviously it is unstable.
Therefore, H plus, we know that oxygen has lone pair over here.
Yeah.
So now as we know oxygen has lone pair, so therefore it will attack H plus and it will form CO H plus C, giving a C double bond O H.
Right.
Here H, here CH3 and CH3. And now as oxygen has plus charge, therefore it will take the electrons from this CO bond and this bond will move over here, giving out minus H plus and minus CO2, forming C double bond C OH H CH3, which is an enol compound
Okay.
and which can get tautomerized to a aldehyde compound.
Right. So here is tautomerization taking place.
So this is what our final product is.
Right. So that was question number 9.